Hi, we're going to be looking at some of the properties, the symmetry properties of circular functions. Firstly, we need to go around and name the quadrants. Here in the positive direction of y and the positive direction of x is the first quadrant. Then we go anti-clockwise, so over here is the second quadrant. Keep going around, we have the third quadrant. And the fourth quadrant. Now, if you can remember, there is a relationship that any of the x values for any of the coordinates around the circumference of the circle. So if I was to pick a point here, for example, the x coordinate would be equal to cos of the angle, where this is the angle from the centre to the x-axis, and the y-coordinate would be sine of the angle. Looks like SRN, SIN. So sine relates to y coordinate, and cos is the x coordinate. When we start looking at the relationships that we have, so if I was to pick a point here, like I did before, and write the coordinates of it, so I have an angle of theta, and as we said before, the x coordinate is cos of theta, and the y coordinate is sine of theta. Now, to look at some of the symmetry which is happening, if we were to go through into the second quadrant with an equivalent angle, we would end up with the same y coordinate or the same sine value. So the equivalence of that is that in the second quadrant, to get the same sine value, it's still the same angle of theta with relation to the x-axis. So this angle here would actually be pi take away theta. Okay, and the coordinates of that are going to be point here, pi take away theta. The x coordinate is actually going to be a mirror image of the positive or the first quadrant angle, so it's going to be negative cos theta, and the y coordinate is going to be sine of theta. They have the same y coordinate, mirror image, we get the negative of the cos coordinate or the cos value from the first quadrant. Now, if we take this first quadrant value and then we go down into the fourth quadrant down here, then you should be able to see that for this one here, it's going to have the same x coordinate, so the x coordinate is going to be cos of theta. The angle that it makes with the x-axis, again we have a mirror image across the x-axis, so it's the same angle. And the symmetry of that, therefore, is that the y-coordinate will be negative sine of theta. And then we can take these two into the third quadrant down here, where we complete our little bit of symmetry. And you should be able to work out here that the x-coordinate is going to be negative cos of theta, and the y-coordinate is negative sine of theta. from this we can work out some relationships. So in the second quadrant, if we were to remember that this angle is pi take away theta, then what we can say is that sine of pi take theta is actually equal to, it's the same y coordinate as the first quadrant, so it's actually equal to just sine theta. We can also go cos pi take away theta is equal to, this is the negative of the first quadrant cos, so it's actually equal to negative cos theta. And if you can remember the relationship that tan has, that tan is equal to sine over cos, or you can go through and you can work out your tangent line, and you can take the value and it passes through the origin. So if we're in the second quadrant, starts here, passes through the origin, and it hits the tan in the negative realm down here. If it was in the third quadrant, it would go through, hit the tangent line in the positive realm. First quadrant's positive, fourth quadrant's negative. Okay, we can then continue our relationship here that tan pi take away theta will be equal to, in the second quadrant, tan is negative, so negative tan of theta. If we go into the third quadrant, then the angle that we're looking at here is actually going to be an angle of pi plus theta. And if we're dealing with degrees, it will be 180 plus theta. So for our third quadrant relationships, we've got sine of pi plus theta. It's going to be equal to, sine is the y value, so it's actually going to be the negative equivalent of the first quadrant, so it's negative sine theta. Cos of pi plus theta will be equal to, now over here we've got a negative x value, so it's going to be the negative equivalent of the first quadrant. And then for tan pi plus theta, that will be equal to, tan is sine divided by cos, so negative divided by negative is a positive, so it's going to be positive tan of whatever tan is in the first quadrant. Theta. And if we come across to the fourth quadrant, the angle that we're looking at here is going to be 2 pi take away theta. So our relationships that we have, sine of 2 pi take theta will be equal to, now down here we have a negative y coordinate, so it's going to be the negative equivalent of the first quadrant. Cos of 2 pi take theta. Down here we've got a positive y coordinate, positive x coordinate, so it's going to equal the same as the first quadrant version of theta. Tan 2 pi take away theta will be equal to, we have negative divided by positive is a negative, so it's going to equal negative tan of theta. Now, if you can have a bit of a look at what's happening there, in the first quadrant, our x coordinate and positive divided by positive is a positive, so all of sine is positive, cos is positive, and tan is positive. So we can say that they're all positive in the first quadrant. If we go to the second quadrant, then the only one which is positive is sine. So only sine is positive there. If we go to the third quadrant, the only one which is positive is tan. So we can say that tan is positive down here. And if we go to the fourth quadrant, the only one which is positive, the value of x, is cos. So we say that cos is positive down here. So the way that that can be represented, if I just reduce all of this, is we can have a simplified version of our unit circle, which is just looking for what's positive. They're all positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, cos is positive in the fourth quadrant. So you might want to call this cast, like so, or I've had students that have called it starting first quadrant going around this way, acts. So you can remember whichever way you want with that. Just a good thing to remember which quadrant is positive at any point in time when we're answering questions. So for the first example, if we're looking at pi take away x, which quadrant is that going to be? Pi take away x will be up here in the second quadrant somewhere. So it's in the second quadrant. So sine is positive in the second quadrant. So we can say that sine of pi take away x will just be equal to sine of x. We're being told that sine of x is equal to 0.6, so therefore sine of pi take away x will be equal to 0.6, and it's positive 0.6. If we go to the second question here, we're looking at pi plus x, so pi plus x will be down here in the third quadrant. In the third quadrant, sine is negative, so that tells us that sine of pi plus x will equal negative sine of x. And we know that sine of x is equal to 0.6, so that tells us if we go down to this third example, 2 pi take away x. 2 pi take away x is down here in the fourth quadrant. In the fourth quadrant we have a negative value of sine. Sine is negative, so sine of 2 pi take away x will be equal to negative sine of x. And we're told that sine of x is 0.6, so it's going to equal negative 0.6. And then for this last example, sine of negative x, what we need to do is we start at 0 and we head around in the negative direction. So sine of negative x is actually going to be in the equivalent of the fourth quadrant. So that tells us that sine is negative. So sine of negative x will be equal to negative sine of x, which will equal sine is 0.6, so it's equal to negative 0.6. Let's do a couple of cos questions. Need to take the same approach with these. These are all in degrees and not in radians, so we'll be dealing with 180, but it all works exactly the same, so we'll have our little unit circle to see which quadrant things are in. We're told that cos of x degrees is 0.8, so the first one here, cos of 180 take x. 180 take away x is in the second quadrant. So cos has a negative value of x, so cos will be negative. So that will tell us that cos 180 take away x equals negative cos of x. That will equal cos x is 0.8, so this will equal negative 0.8. For the second one here, 180 plus x. 180 plus x is down here in the third quadrant. Third quadrant again, we have cos is negative. If the x coordinate is negative, cos is negative. So that tells us that cos 180 plus x will equal negative cos of x, which cos x is 0.8, so this would be just negative 0.8. Then this third example, 360 take away x. 360 take away x will be down here in the fourth quadrant. Always good to identify the quadrant first. In the fourth quadrant, cos has a positive x coordinate, so cos is positive. So that'll tell us that cos of 360 take away x, and it should be right in these degree symbols everywhere, shouldn't it? Over there. Yep, we'll get there. And that's going to equal just the positive version of cos of x. And that will be equal to 0.8. And this fourth example, as we said before, negative x, it's a negative direction, so it's going to take us down again into the fourth quadrant, where cos is positive. So cos of negative x degrees will be equal to cos of x degrees, and that will just equal 0.8. Okay, I hope you find that useful.